Hi, my name is Yojazi and I am the leader from Group 5 Structural Analysis and Design from Section 1. Today we are going to present our Structural Analysis and Design project, and now I am going to introduce all of my group members. First is me, Yojazi, and the second one is Alvin Lingzila, and the third one is Nofarisha Nohiman, and the next one is Nurul Amira Balkis.
Very good day to all. Today I'm excited to present the design report for our proposed residential home project that located in Persiaran Perdana, Precinct 4, Putrajaya. This project involves in designing and analyzing a single-story residential structure using reinforcement concrete. Our primary goal is to ensure the building is not only functional but also safe and compliant with all relevant building codes and standards. In the part of our design and analysis, we include structural elements. We have focused on critical components such as beams and slabs in this part. Secondly is load determinations. An accurate calculation of various loads is crucial to ensure the structure can support and transfer these loads effectively. Thirdly is the moment and shear force calculation. This calculation helps us to understand the internal forces at play within the structure. After that is reinforcement selections. Choosing the appropriate reinforcement is crucial for maintaining the structural integrity and durability of the building. Last but not least is structural element detailing. Ensuring that every detail meets the standards and contributes to the overall stability and safety of the structure is very important too.
Okay, for the theory part, first for beams are designed to resist various forces such as bending moment, shear force, and torsion, and as well as fulfill specific serviceability requirement to ensure safe design. Designing a beam involves considering factors like weight, material, size, shape, cracking, deflection, and shear force, and bending moment. Next, as for the theory for slab, also known as a flat horizontal structural member that is usually composed of concrete. It is used to construct floor, roof, and ceiling in structure. And the slab divided into two types, which is one-way and two-way. This has function to determine the appropriate thickness, calculate shear and moment forces accurately, and describe reinforcing correctly. As for one-way slab, it is more and way simpler to construct and suitable for shorter span. And as for two-way slab, it is more complex and support longer span and heavier load. But as for both, require adherence to specified design method and pertinent rules and standards to ensure safety, usefulness, and longevity in various building applications.
Alright, now I will be presenting the analysis and design of a simply supported beam. Firstly, let's look at the specification of our beam. The effective span of our beam is 2.7 meter and the GK is 10.092 kN per meter and QK is 5.102 kN per meter. The design life is set to be 50 years with a fire resistance rating of R60 and an exposure class of XC1. Now, we calculate the total design load. This includes both the permanent load and variable load. Adding this together gives us a total load W, which we will use in the further calculations. Moving on to the reinforcement design, we firstly calculate the required area of the steel reinforcement, which denoted as AS. Using the appropriate formulas, we determine the necessary amount of steel to resist the bending moment. Additionally, we calculate the spacing for shear reinforcement or stirrups to ensure the beam can handle shear force effectively. Last but not least, cracking and deflection check is also very important. Deflection control is a critical aspect of beam design. We must ensure that the beam's deflection under load does not exceed the permissible limits. Here, we calculate the deflection and compare it to the limits, ensuring the beam's performance meets safety standards.
Hi, my name is Yozazi, and today I'm going to present a calculation of continuous beam. So this is the continuous beam that I select if my plan. First of all is the specification part. The assumed diameter of bar 1 is 20 mm, the assumed diameter of bar 2 is 15 mm, and the assumed diameter of link is 10 mm. Next is the durability, fire and bond requirements. The minimum concrete cover regard to bond is 20 mm and regard to durability is also 20 mm. And the minimum required exit distance for R60 fire resistance is 30 mm and the nominal cover is 25 mm. The next part is loading and analysis. This is the value of GK and QK of each span from the beam. And for the span 2-1, the WD value that I get is 36.4 kN per meter, and the value for span 2A2 is 35.9 kN per meter. And for the part of span 3-2A, the area of tension reinforcement is equal to 49.46 mm squared, and the minimum and maximum reinforcement area is still the same. For the part of shear reinforcement, the concrete structure capacity VRD max is equal to 105 kN, where the angle is equal to 22, and E is equal to 151 kN when the angle is equal to 45. For the support one, the VED is equal to 54.92 kN, and the angle is considered as less than 22. And the next one is the value of shear links. The value I get is 0.22, and the value of spacing S is equal to 259.09 mm, which is greater than 0.75 times D. And for support 3, the value of VED is equal to 14.61 kN, and the value of shear links is equal to 0.059, and the spacing is equal to 966.1 mm. For support 2, the value of VED is equal to 36.12 kN, and the value of shear links I get 0.15, and the value of spacing I get 380 mm. And for support 2A, I use all the same formula to get the answer. And finally, I will get the value of spacing is equal to 791.67 mm. And for the additional longitudinal reinforcement, it's usually applied to the support which is at the center part of the beam, like support 2 and support 2A. So these are the answers that I get for the support 2 and support 2A. And the next one is the calculation of minimum links. The value of ASW over S that I get is 0.11, and the spacing S I get is 518 mm, and the shear resistance of minimum links is equal to 28.34 kN. And for the next one in link arrangement, the value of x1, x2, x3 is 0.73, 0.3, 0.22 meter respectively. And for the part of deflection, for the span 1, 2, the factor for structural system K is equal to 1.3, and the value of L over D that I get is 17.3. And the modification factor for steel area provided is equal to 13.15, which is less than the value of L over D allowable, so E is considered as okay. And for span 2-2A, the allowable span effective deck ratio L over D actual that I get is 7.17, which is also less than the value of L over D allowable, so E is also considered as okay. And for the span of 2A3, all the calculation is still the same. And the allowable span effective ratio L over D actual that I get is 5.98, which is also less than the value of L over D allowable, so E is also considered as okay. So for the part of cracking, for span 1, 2, the steel stress is equal to 363.36 kN per meter, and all the span have the same spacing S, which is equal to 7.5 mm. For the span 2A2, the Fs is equal to 362.85 kN over meter, and for the span 2A3, the steel stress is equal to 364.45 kN per meter. And lastly, this is my detailing part.
As for calculation of continuous slab, we also have to specify the specification first, which is the effective span, characteristic of action, characteristic of materials, and assume diameter bar. Once we identify the specification, we can move to the next step, which is to calculate the slab thickness. From the specification, we can also identify the nominal cover, which is the C norm, and then we can identify the characteristic of permanent action, which is GK, and characteristic of variable action, which is QK. And apart from that, for continuous one-way slab, we got the total is 72 meters squared for area of bay, and as for QK divide to GK, our total is 0.633, which is smaller than 1.25, and it is considered as 1 meter width of slab. As for the information that we gather from the previous calculation, we can finally form a moment and shear body diagram. We move to the next step of calculation, which is main reinforcement. First, as for starters, we need to find the effective depth, and then we can proceed to identify the minimum and maximum reinforcement area. As for the total, we can identify the secondary bar size. As it shown in this slide, from the effective depth, we also can determine the near middle of end span of sizes. We can get at interior support and interior span, and at outer support. As calculation for shear, we need to identify the maximum at design shear force, which is first we need to find the VED and proceed to design shear resistance, which is VRDC. Apart from that, we need first to find the value of K, the row 1, and lastly we can get the total of VRDC. Lastly, after we identify the VRDC total, we can identify the Vmin value. So for VRDC, for our project is 50 kilonewton, which is bigger than VED. Okay, for the next step of calculation is deflection, which is we need to identify the percentage of required tension reinforcement. As for example, we need to find the amount of rho and rho 0 in order to find the modification factor for span that is greater than 7 meter, and we need to find the modification factor for steel area provided. As for our project, as you can see here, our actual span effective depth is allowable and okay to proceed to the next calculation, which is cracking. In the cracking area, we need to identify the main bar sizes, whether it's okay or not for maximum bar spacing. And lastly, once we complete all the calculation for the continuous slab, we can finally do the detailing. As you can see here, these are 2 point of view for the detailing.
Assalamualaikum and hi, I am Nofarisha. Now I would like to present the calculation of resilient two-way slab. As you can see in the slide shown, all the specification of the two-way resilient slab for our project, I choose to calculate slab CD12. In the diagram shown on the slide, the long span Ly is 5182 mm and the short span LS is 3048 mm. To determine whether the slab is one way or two ways, we need to use the formula Ly over LS, and if it is less than 2, therefore the slab is two ways. So in this case, Ly over LS is equal to 1.7, so it's proved that the slab is two-way slab. Then we move to the slab thickness. The minimum thickness for the fire resistant R60 as mentioned in the specification is 80 mm based on the table 5.8. So the estimated thickness considering diffraction, H we get 102 mm. Therefore use H equal to 120 mm. Move to durability, fire and bond requirement. This is the calculation for this part, as you can see in the slide. Next, for the action part, as you can see all the detail in the slide, we use the formula ND equal to 1.35 GK plus 1.5 OK for design action, and we get 29.06 kN over meter square. After that, move to analysis part. The first thing, we calculate the bending moment of short span and also the long span. Then we move to the main reinforcement. We need to find the effective depth, that is the X and the Y. For this slab, we get 90 mm and 80 mm respectively. By finding the minimum and maximum reinforcement area, we can decide our scanner bar that we use, that H then 4 to 5. Now move to short span. This is the calculation we need to do as shown in the slide. In this part, we find that we use H10 150 for bottom and H10 100 for top. The same step will apply in long span, and we get H10 275 for bottom and H10 200 for top. Next, we calculate the shears for the slab. You can see the calculation detail in this slide. In this part, VRD is equal to 60.29 kN more than VED, so the value is satisfied. Next, we have deflection, and this part also the value is accepted. Move to the part, and this value also accepted. As you can see in the slide, this is the detailing for this resilient two-way slab for our project.
As a conclusion, the project effectively demonstrated the construction of a single-story residential building using structural engineering principles. Overall, the project not only delivered a comprehensive design for residential structure, but also emphasized the importance of combining theoretical principles with practical considerations to achieve a robust and reliable outcome.